Algebra 1, Lesson 73, factoring the difference of two squares. So this is my favorite because it's easy. Don't you like things that are easy? I do. All right, factoring the difference of squares. So when we say the word, we say the word factor, what do you think of? Factor, what do you think of? What's the opposite of factoring? Diana? Any idea? No. Is factoring like, you have an idea, I can tell.
Maybe dividing.
Okay, yeah, factoring is like dividing, right? You're dividing something out, okay? Separating, okay, it's the opposite of multiplying or distributing, right? Distributing multiplies something in, factoring takes it out, right? Yes, okay. Difference, what do you think of when you see difference? Subtraction, right? It's the answer in a subtraction problem. And squares. Do you hear 1, 4, 9, 16, 25, 36, 49, 64, 81, 100? Right? 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 100, what? 44, 169. Oh, feeling very low today. 196, 225. Those are all perfect squares, which means that you can just say, what's the square root of 49? And it's 7. If I said, what's the square root of 20? Not that easy, right? You have to solve it. Okay, these are perfect squares, so they're easy. So factoring the difference of squares. Now, to show you why it works, we'll do the opposite of factoring, which is distributing. So let's say we had x plus 3 and x minus 3. Okay, we had this, and you can just watch. You don't have to write this out. We want to distribute. What would we do? Multiply x times, and then x times, or like negative 3, right? And then you would multiply what?
3 times x, 3 times negative 3.
Right. Okay, so if we did that, we would get x squared minus 3x plus 3x, what? Plus 3 times negative 3 minus 9. And when you simplify that, what do you get? Oops, sorry, this is an x squared. Nobody's paying attention, how dare you? What does that become?
X squared minus 9.
Yeah, the negative 3x and the positive 3x cancel each other out, so you're left with x squared minus 9, which is what? A difference of squares, right? It's still going. Okay, that's that. It's a difference of squares. So if we were to go backwards and you recognize this, normally when we get a factoring answer with these two parentheses, it's a trinomial. It's a trinomial, right? Like if we had x squared plus 7x plus 10, and I said factor that, you would set up your parentheses, and you would put in x and x, factors of 10 that add up to 7, or what? 5 and 2, and you'd be done. Or if I had something like 2x plus 10, or even 2x minus 10, how would I factor that? Would I set up two parentheses? No. No. I would just, is there anything you can factor out? Any common factors? Yeah, a 2. If I factor out a 2, I'm left with x minus 5. Okay, so this is typically how you factor a trinomial, and this is usually how you factor a binomial, 2 terms. But this is a special binomial. It is the difference of squares. And the difference of squares is actually factored using two sets of parentheses. So, and how do we do it? Well, we take the square root of x squared, which is square root of x squared, x. And what's the square root of 9? 3. And you take those square roots and you add them, and you subtract them. Right? Those are equal. These two are equal. You saw that. So we can do that for any of them now, and it's very, very fun and easy. Right? Okay, so let's do practice problem A. That says 64x squared minus 81y squared. So, can you identify this as a difference of squares? Yes? If you can, then you should be able to tell me what the square root of each term is. So, Diana, what's the square root of 64x squared? 8. 8x. Talia, what's the square root of 81y squared?
9y.
9y. So, my answer is what? What do you think?
8 plus x.
No. 8x, right? We take this and this, just like here. We took the x and the 3. And
8x plus 8.
8x plus
9y.
9y. That's what we did here. We took the x and the 3 and we added them and subtracted them. So we get 8x plus 9y and 8x
Minus 9y.
minus 9y. Ta-da! B says negative 25 plus 100 m squared. Oh, I didn't bring any water. Thirsty? No, we don't have any. Now, how does this one look different than the other one? Does it look different than the other one? Yeah, what do you think, Ethan? What's different?
Only the 100 has an exclamation, so, or a letter, so
That's true. Only
the
the
other one's negative.
one is negative. Which one is negative?
25.
Right. And in the order of the terms, it's different, right? This one had a negative, doesn't it? It has a negative, but it's here. So what if we just switch these? If we switch the order, then we would have 100 m squared minus 25. Is that a difference of squares? Oh yeah? Then what are they? What? Ethan, what's the square root of 100 m squared? 10.
M squared, or 10m.
That's right. And then the square root of 25? 5. So my answer is, you take those two, 10m and 5.
And then you add them
So I'm gonna get
100, or 10m plus 5. Then 100m, or yeah, 100m.
10m.
10m minus 5.
Right. Do you see why I love these? last one I went to try it around. Oh, can you see that? Up there. Hmm?
Can you help me?
Yeah, sure. So we always are looking for, okay, so here, 10m and 5, so what is going to be the square root of that, those two? How do you find the square root of n variable with an exponent?
Get the flip it.
Well, for the m squared, we took half of it, and is m, basically, m times n is m squared. So what times what is y4?
Y2.
That's right. And then what's the square root of x squared?
X one.
Just x, yep. And then 169, what's the square root of that? Is that a perfect square? And,
Values.
yep,
13.
good, yeah. And then you have z10, so that would be,
Zika.
right. And you can put your parentheses and add them and subtract them. All right, so the general consensus seems to be, what did you get, Talia?
Y squared x,
Okay, and how did you get y squared?
because it's half of y to the fourth.
Right, so when you have exponents, you're going to divide them in two to find the square root. And then here,
And then there, 13, c5,
so your final answer is?
y squared x plus 13c to the fifth. And the next one is y squared x minus 13c to the fifth. Right.
Good, done.